Okay, thank you, madam.
Thank you, ma'am.
In the contemporary educational landscape, tools and technologies have become integral to teaching and learning. In the dynamic landscape of learning, educators are increasingly leveraging technology tools to enhance teaching and learning experiences. These tools, ranging from interactive whiteboards to the educational apps and virtual learning platforms, bridge the traditional methodology with the innovative approaches. Technology in the classroom not only cultivate digital literacy but also foster collaborative and personalized learning. From gamified educational apps that engage students to online resources catered to interactive lessons, track student progress, and adapt teaching strategies in real time. So now we will start. Myself, Dr. T. Premalata, Assistant Professor from the Department of Education, School of Distance Education, Bharatiyar University. The topic is leveraging technology. What is leverage? Any comment on that? You can use the chat box also for that. What is leverage? May I know the meaning for the word leverage? Yes, any? What is leverage? Okay, let me proceed. Leverage, it means to use something that already we have in order to achieve something new or better. So using something that which we are having already to achieve something new or better is a leverage. That is replacing the old one with something new one. Leveraging on technology, given on leveraging technology. So leveraging on technology, it is a practice of optimizing the use of the digital tools in the workplace to help the organization succeed. To leverage the technology, you can update internal system, replace the outdated tools, and train the team members for using new technology. Here are some technology, how the technology follows the some things. Number one is access to information and learning resources, personalized learning, interactive and engaging learning, collaboration and communication, assessment and analytics, inclusion and accessibility. What is access to information and learning resources? One of the most significant of technology in education is the easy access to the vast amount of the information and the learning resources. The internet has become a treasure of knowledge, making educational content available to anyone with a device and the internet connection. So this accessibility breaks down the barriers to learning. The next comes is personalized learning. Personalized learning. Each student has unique learning preferences and abilities. Technology allows the educators to take promoting the personalized learning. The third one is interactive and engaging learning. Traditional classroom settings often struggle to maintain student engagement. However, technology offers most of the interactive tools and the resources that can captivate student attention and make learning more enjoyable. The fourth one is collaboration and communication. Technology has redefined the concept of classrooms by breaking down physical barriers. Virtual classrooms, video conferencing, collaborative online platform enable the student and the teacher to connect global. This connectivity promotes cross-cultural understanding, facilitates collaborations on projects, ideas. The fifth one is assessment and analytics. Traditional assessment often falls short in capturing comprehensive understanding of the student ability. Technology-enabled assessment offer real-time analytics indicators with deeper insight into the student progress. The last one is inclusion and accessibility. So technology plays a vital role in promoting inclusivity and accessibility in education. So the technology is leveraged in education in these forms. Number one, access to information and learning experience, personalized learning, interactive and engaging learning, collaboration and communication, assessment and analytics, and inclusion and accessibility. Next one. Next slide. The topics, next slide, please. The topic is related to innovative technology and tools to enhance teaching and learning. Next slide. அதுக்கு முன்னாடி slide. Yes, this one. Slide, next slide. Third slide. Yes, this one. The topic is related to innovative technology and tools to enhance teaching and learning. Let me start with the innovative technologies in education and then proceed with the tools in education. The capability of emerging trends in educational technology to personalize learning, provide access to quality education, creative interactive experiences, enable data-driven decision making. Therefore, as technology advances, for educators and academicians to continue to remind of these developments. The biggest transformer ever occurred in the education sector brought some substantial changes with technology. Education sectors are incorporating emerging technologies like artificial intelligence, machine learning, big data, augmented reality, virtual reality, cloud computing, data analytics, Internet of Things, and similar others that are making a difference in the higher education process. These are some of the innovative technologies, that is the emerging technologies in the field of education. Next slide. Next slide. Augmented reality, AR. Augmented reality is the integration of the digital transformation with the user environment in real time. Unlike virtual reality, which creates a totally artificial environment, AR users experience a real world environment with perceptual information overlaid on the top of it. Thomas Caudle coined the term augmented reality in 1990. Augmented reality is used to either visually change the natural environment in some way or to provide additional information to the users. The primary benefit of AR is that it manages to blend digital and three-dimensional components. AR has variety of uses from helping in decision making to environment. In the field of education, that is in the classroom, we can use augmented reality to provide interactive experiences to make learning more engaging, provide additional text to the environment, and make remote learning feel more like in-person learning. Augmented reality helps the students view the complex models such as anatomical model in the classroom space. The AR delivers visual elements, sound, and other sensory information like smartphone or glasses. This information is overlaid onto the device to create an interwoven experience where digital information alters the user's perception to the real. Thomas Caudle, previous slide. Previous slide. Thomas Caudle coined the term augmented reality in 1990. He is a person who named as augmented reality. The next one. Next slide. History of augmented reality. I wish to give a short history of augmented reality. The augmented reality become encompassing various sectors ranging from gaming to education, healthcare to marketing. But the history of augmented reality is longer than we might think. In 1990, Boeing researcher Tom Caudle coined the term augmented reality to define the integration of computer generated images into the real world. After 2 years, that is in 1992, Rosenberg established the first entirely immersive AR system at the US Air Force Research Laboratory. In the late 1990s, that is during 1998, augmented reality was first used for navigation in NASA. The year 2000 witnessed the launch of a pioneering AR game, AR Quake, where players were equipped with the backpack that housed a computer and the gyroscopes. The early 2000, that is during 2005, saw the debut of augmented reality app for smartphone, AR game, AR tennis, developed for Nokia phones in 2005. In the early 2000, the first AR app for smartphones surfaced, including the Nokia phone's two-player AR tennis game in 2005. In 2008, TBMW was the first brand to make use of AR for commercial purposes. In 2012, Blipper released the first cloud-based AR app. 4 years later, Niantic and Nintendo launched Pokemon Go, the hugely popular location-based AR game. The same year, Microsoft unveiled HoloLens, an untethered holographic computer. Looking back, the history of AR has been marked by innovation and expansion with many exciting developments yet to come. Next slide. AR. Augmented reality is no longer science fiction, and it isn't just for gamers. AR superimposes digital imagery into our field of vision, meaning partially or fully replaces our unaugmented view. Within this basic interpretation, there are few different types of augmented reality. Augmented reality, it is divided into two main types. One is marker-based augmented reality, and the other one is markerless reality. Under marker-based augmented reality, it is only one type under marker-based augmented reality. There are four main types under markerless augmented structures: projection-based augmented reality, location-based augmented reality, overlay augmented reality, contour-based augmented reality. Next one. So the different types of augmented reality are marker-based augmented reality and markerless-based augmented reality. Under markerless AR, projection-based augmented reality, location-based augmented reality, overlay augmented reality, and contour-based augmented reality. Next one. Yes. Click again. Reality. Marker-based augmented reality leans on a visual marker to activate the altered interactive experience. The most common markers used are QR code, short for quick response. A device camera recognizes the machine readable barcode, and respond by producing visual effect. Marker-based augmented reality was once groundbreaking. It has some limitations. The technology can usually only be used with the mobile devices such as smartphone or tablet. Also, users have to download the app or software in order to experience. So, marker-based augmented reality does not have become so accustomed in our daily digital life. Markerless augmented reality. Markerless augment, next one. There are four main types of markerless augmented reality. The two primary types of markerless reality are projection based and location based. Projection based augmented reality. As the name suggests, projection, one by one, please wait. As the name suggests, augmented reality projects immersive light onto the flat surface to create the 3D imagery. Projection augmented reality is a type of augmented reality that uses project digital content onto the physical surface. This can be done in real time or pre-recorded. The projection-based augmented reality typically use a camera to track the position of the user's head and a projector to project the images onto the surface in the environment. The images are then tracked by the camera so that they can be interactively manipulated by the user. Under the projection-based augmented reality, there are four common types. One is medical augmented reality, then military augmented reality, and industrial augmented reality. This medical augmented reality is often used in the medical training and surgery, as it allows doctors to see a patient's anatomy in real time without having to make incision. We can project and the doctors can do the surgery. Military AR. This type of AR is used in the military field to help the soldiers plan and execute mission as well as to provide them with the information about their surroundings. Industrial AR. This type of AR is often used in manufacturing and assembling. The second one is location-based augmented reality. With the location-based augmented reality, the content is fixed to a specific physical space. It maps the real-world environment and defines visual positions in our surroundings. Once our device detects a match with the mapped location, it superimposes digital imagery. The location-based augmented reality heavily depends on the real-time location system. These systems are the ones that identify the present location of the user process. Example for location-based AR. Many brands now use AR technology in general, but some have started the location-based AR, such as Vortex Planetarium. See, in this planetarium, they allow everyone to look into the sky and see all the stars. Madam, நான் சொல்றேன் ma'am. The location-based augmented reality is these are the common example. One is Vortex Planetarium, IKEA Place, where we are doing furniture shopping, Magical Park. It is creating the fantasy from the real life park of Australia. Star Walk. Star Walk is another fascinating astronomy application that is used to see the world of star and the planet in the New York Museum of Modern Art, Florence Travel Guide. These are some of the examples for location-based augmented reality. The next comes contour-based augmented reality. The contour-based augmented reality or outlining AR, which leverages SLAM to outline the silhouette of the objects and stimulate a realistic human interaction. For example, it might be used to develop a safe driving application for the nighttime, poorly lit roads, heavy precipitation, and other low visibility situations. So there are four main types of markerless augmented reality. Next one. Next slide. Yes. Click again. Artificial intelligence. Artificial intelligence is another new innovative technology that mimics human behavior or thinking and may be educated to solve the issues. Artificial intelligence is a successor of machine learning and deep learning approaches. In true terms, the field of AI research was founded at a workshop campus of Dartmouth College during the summer of 1956. At that time, it was predicted that a machine as intelligent as human being would exist in no more than a generation. And they were given millions of dollars to make this vision come true. Next, click next one. History of artificial intelligence, 1950, the time when it all started. So until 1950, people were unaware of AI. John McCarthy is known as the founder of artificial intelligence, and he introduced the term artificial intelligence in the year 1955. Carthy, along with the Allen and Herbert A. Simon, is known as the founding fathers of AI. So in 1974, computers flourished. Gradually, with time, the wave of computers started. With this time, they become faster, more affordable, and able to store more information. 1980 is called as the year of artificial intelligence. In 1980, AI research fired back up with expansion of fund, and it is a landmark of AI establishment achieved. It was in 2000s that the landmark goals of AI were achieved. At that time, AI thrived. Next slide. Types of artificial intelligence. AI is a vast term covering different subsets. For instance, some need big data, machine learning, or natural language processing. We can classify AI into four separate types based on the Maslow's hierarchy of needs. They are reactive machines, limited memory of mind, and self-aware. What is reactive machine? Reactive machines are the machines perform basic operations and the simplest AI type. The type of AI reacts to some input with some output. They cannot create or valuable information to influence future decision. So the reactive machines cannot create any memory. They can only respond to currently existing situation. This model serves no input, it performs no learning. So reactive machines cannot create any memory and they cannot give any valuable information. Then comes the limited memory. As the name suggests, this type of AI can retain some data learned from the observing the past events. For instance, self-drive cars store the pre-programmed information such as map, observing surrounding information like direction and the velocity of the cars nearby. There are three kinds of models that achieve limited memory. They are reinforcement learning, long short-term memory, and eGAN. Reinforcement learning. They learn to improve the predictions through several trial and error. Long short-term memory to forecast or tag more latest information. And the eGAN, this model has a memory that evolves at every evolution. Type is theory of mind. This type of AI is not completely implemented yet. We are the only at the nascent stage, and this type of AI model can be seen in the self-drive cars. Here, AI interacts with the human emotion and thoughts. Humans have emotions, feelings, and memories that influence their behavior. Experts have yet to develop the theory of mind technology, without which Sophia is just a chatbot with a face. The fourth type is self-aware. These are the most complex AI machine. Aware machine, it would not just know of inner state, but can predict the feelings of the others around it. For example, as humans, if for us, we know that they are upset, as we understand how we feel when we cry. So self-aware, these machines have human level awareness and understand their existence in the world. Next slide. Of artificial intelligence. There are endless examples of how artificial intelligence has impacted our lives, like personalized e-commerce, smart cars, healthcare, virtual assistants, hospitality, surveillance, customer support, social media, and marketing. Still many more. Next one. Next slide. The next important technology in education is Internet of Things, IoT. IoT stands for Internet of Things, the network of connected devices and the technology that facilitates communication between them. Emerging IoT consumer trends like smart active wear, smart sports shoe, and connected cars tells us how close we are to the vehicles around us. In brief, the things in the Internet of Things are the everyday objects in our house, only hooked up to the Internet. It is really cool. Next step, next slide. The birth of Internet and IoT. Part of IoT. And the invention of connectedness itself is the first milestone in the history of IoT. In 1962, JCR Licklider, the head of the Defense Advanced Research Projects Agency, DARPA, envisioned a galactic network of interconnected set of computers. His concept later evolved to ARPANET, Advanced Research Project Agency Network. By 1980, the ARPANET was commercialized for public use, and thus the Internet was born. In 1989, David Nicholas and his colleagues at MIT invented the first IoT device, and this was followed by John Romke and Simon Hackett creating the Internet Toaster in 91. The Internet Toaster was a big milestone as John Romke and Hackett successfully connected the toaster to the Internet and managed to turn it on and off remotely. Dr. Quentin Stafford and his colleagues at the University of Cambridge invented the first online webcam. For the same reason, the smart vending machine was invented. A year later, in 1994, Steve Mann creates the webcam, which turned out to be the first major milestone for wearable technology. By now, devices being connected to the internet was becoming a thing. This changed when Kevin Ashton, the co-founder of the Auto ID Labs at MIT, coined the term Internet of Things in 1999. Ashton believed that RFID is a prerequisite for IoT. He was a big believer in the potential of the during the year 2000, LG announces the first smart refrigerator. It paved the way for the commercialization of IoT. In less than a decade of coining the term, Internet of Things had become a phenomenon. The United Nations published its first report on the Internet of Things in the year 2005. The UN report predictions were pretty apt as just 2 years later. Apple announced the first iPhone in 2007. Although the first ever smartphone would be the Simon personal communicator created by IBM, Apple was the first iPhone that popularized smartphones globally, even though the first iPhone only allowed users to browse the internet. In 2008, the number of connected devices overtook the number of people in the world. This was the time that IoT was truly born, as the number of connected devices was officially at a stage where any data across the world could be collected if need be. The 2000 was an exciting decade for IoT, as several milestones were achieved in short period. As the technology and the utility rapidly evolved, IoT could finally be a part of everyday life. In 2009, Fitbit released its original activity tracker. This was the first wearable activity tracker that paved the way for modern smart watches. So the original Fitbit activity tracker is released during the year 2009. As we enter the 2010s, IoT milestones started getting more technical and more specific. The underlying technology had already evolved enough that subsegments could start evolving on their own. In the year 2011, IIoT comes into being. In the year 2014, Seoul becomes the and first world smart city. IoT truly went mobile in 2000 as smartphone, smartwatches, health monitors, GPS trackers became a household scene. As global spending on IoT increased, business started investing in the technology. IoT platforms started cropping up. AWS launched IoT Core in 2015 and rolled it completely by 2016. This was closely followed by Hub in 2016 and Google IoT Core in 2017. In the following years, several IoT platforms were launched, which allowed the business to simplify their IoT project and expand into IoT space easily. As a result, in 2021, the number of connected devices surpassed the number of not connecting devices worldwide. To take the note, World Economic Forum one of the three most impactful technological advancement. So the history of IoT is full of fun experiments, complex evaluation, and some major industry overhaul. So the history of IoT starts from 1962 with the evolution of internet, and still it is growing. Next slide. Next slide. Kevin Aston, born in 1968, technological pioneer who co-founded the Autos ID Center at MIT, which created the global standard system for RFID and other sensors. He is known for coining the term Internet of Things to describe a system where the Internet is connected to the physical world through sensors. So Kevin Aston is acknowledged as the father of Internet of Things. Next slide. Next slide. Areas of applications of IoT. The Internet of Things will have its effect on every home and business on the earth in the next 15 years. IoT applications use technology to improve our comfort, use less energy to do a task, and give us great control over our lives. There are few critical application areas of IoT, such as smart cities, energy engagements, wearables, home appliances, agriculture, cars, smart manufacturing, transportation, healthcare, and smart homes. Most of the IoTs are now in use. So these are the areas where we are using IoT. Next slide. Next, cloud computing. This is another important technology, and it is a well-known term for nowadays. It is a buzzword in IT industry. Cloud is a term that refers to the internet or network. It represents something present at a remote location. Cloud computing is delivering computing power such as CPU, RAM, storage, databases, networking, operating system, etc. Cloud computing helps us to reduce the cost of IT infrastructure and computer for the users. It gives improved performance. It requires fewer maintenance. We get instant software update. It provides the backup and recovery. Better performance and scalability is possible in cloud. Cloud computing allows much storage capacity and gives more data safety. Next one. Next slide. There are different types of cloud, such as public cloud, private cloud, and hybrid cloud. Three main types are public cloud, private cloud, and hybrid cloud. And the next cloud is community cloud. This public cloud are usually used for business to consumer type interaction. This is called as B2C, that is business to consumer type of interaction. In this type of cloud, the computing resources are owned, governed, and operated by the third-party cloud service provider. So public clouds are used for business to consumer. The most popular example for public cloud is Microsoft Azure. Then comes the private cloud. So private cloud may be physically located on-site data center of the organization. Sometimes companies pay third-party service providers to host their private cloud. The third type is hybrid cloud. Hybrid cloud may be used for either business to business or business to business consumer interaction. Public cloud is used for business to consumer interaction, but hybrid cloud can be used either for business to business interaction or business to consumer interaction. The deployment method is called hybrid cloud because the computing resources are bound together by different clouds. Hybrid clouds combine public and private clouds. It binds private and public cloud together by the technology that allows the data and application to be shared between them. Hybrid cloud provides the business more flexibility and more deployment options by allowing data and applications to move between the private and public clouds. So there are three main types of cloud. One is public cloud, the second one is private cloud, and the hybrid cloud. Public cloud is used for business to consumer interaction. Hybrid cloud is mainly used for business to business interaction or business to consumer interaction. The next slide. Benefits of cloud computing. These are some of the benefits for cloud computing, such as innovation, cost and scale, choice, agility, savings, efficiency, opportunity, flexibility, and reliability. In terms of savings, cloud computing decreases the need for costly hardware and infrastructure. In terms of scalability, cloud computing enables individuals and business to scale their IT resource up or down as required. In terms of flexibility, it enables the employees to access the application and the data from any internet connected location. In terms of reliability, the cloud providers offer high availability and reliability through the redundant system and the data backup. In terms of security, it has the dedicated teams of security experts who ensure data security is stored on their platform. It reduces the risk of cyber attack. In terms of the collaboration, cloud computing provides a centralized collaboration and file sharing platform, allowing the teams to work together more effectively and efficiently. Next slide. Click on yes, yes. Usage of 5G technologies in education. The wireless technology has now seen its fifth generation, also known as 5G. Anyone can use it and enjoy high performance and low latency wireless technology. Students are more likely to benefit from this unique invention that allows them to receive student materials and resources and connect to more powerful networks. 5G technology or the fifth generation technology is the latest upgrade in the long-term evolution mobile broadband networks. It will increase the speed and responsiveness of wireless network to a great extent. Initial trials for this new technology have commenced in many countries worldwide. 5G networks are primarily 100 times faster than the current 4G network. It is presumed to have enormous impact on all sectors of the economy. So 5G will cover 20% of the global population by the year 2023. 5G showcases the kind of penetration, the new technology which we will have in India and in the entire world. Next click. An overview of 5G. To understand the 5G and its relevance, we have to first need to be familiar with the predecessor, which are 1G, 2G, 3G, 4G, and 5G. 1G. 1G model is an analog model. So it is introduced in the early to mid. 1G was the first generation of wireless communication, allowing the people to make simple call between the mobile phone. The data transfer speed will be 1.9 kilobit per second. 2G model, that is GPRS, This was introduced in the year 1991. 2G was the first ever digital cellular technology to offer users voice call, text only SMS message, and internet connection facility with a maximum data transfer 10 kilobytes per second. 3G model UMTS. Coming into the existence in 1998, 3G was a third generation of the wireless mobile technology. It offers the data transfer at least from 200 kilobit per second and maximum 14.7 megabit per second. This technology later led to the smartphone revolution and even make video calls. 4G method, 4G LTE. So this is released in 2008. 4G is the current standard of wireless communication. It allows the users to engage in the data in activities like gaming, video conferencing, high definition live media with the maximum real world data transfer. And now we are about the golden era of 5G. 5G has reached 1 terabit per second, which is roughly 65,000 times faster than the typical 4G connection. In the real world environment, we can expect 5G to deliver consistent data transfer with the speed of 2.8 Gbps. It is really a game-changing technology. 5G technology, we are expecting 20% of the people worldwide will come under 5G technology. The next technology, next one. So for 1G, 2G, 3G, 4G, and 5G, what we are expecting now, the current technology. Next one. Gamification. See, this is contrary to the word what it is given. Gamification is not only playing a game, it involves adding the game techniques to the non-game environment. In 2002, a computer programmer and the inventor named Nick Pelling coined the term gamification. Gamification is a way to motivate the participants. A correct application of the gamification in relearning contributes to intrinsic motivation, longer and more intensive involvement, enrichment of the learning experience, and increasing the learning efficiency. Yeah, next one. Next slide. How I can gamify the classroom. Introducing gamification in the education helps to boost classroom engagement, collaboration, and learning. Ways it can be done. Start giving learning badges instead of gadgets. Games like scavenger hunt, dice games, Connect 4, etc. can be adapted in the classroom learning. Play interesting competition within the class and reward the winners, such as 1 minute dance party, extended recess time, etc. Let our students to set their goals and to track their own progress. We can divide the students in the group and we can make them to play quizzes. So these are some of the ways to do gamification in the classroom. Next slide. Payment gateway. If you wonder why you need payment systems, it is because there were many payment related problems in university or the course fees that take a lot of time and effort. Since students or their parents must go to the educational institution or the centers and stand in the line to make their payments, the time and money spent paying fees spent elsewhere. So students will be able to pay at their own leisure time remotely and in smaller installments thanks to the online and the mobile payment. So these are some of the important technologies which we have seen. Next one. This is very important model, the SAMR model for technology integration. MR model is a 4-level taxonomy that describe how technology impact teaching and learning. The SAMR model can design, implement, evaluate learning experiences. There are 4 levels in the SAMR model for technological integration. One is substitution. The third one is modification, and the fourth one is redefinition. There are 4 levels: substitution, augmentation, modification, and redefinition. The first level, substitution level, here technology acts as a direct tool and substitute with no functional change. It is like swapping a typewriter for word processor. The core of learning remains unchanged, but the digital tools make the process more efficient. Under the substitution, we can use the following digital tools such as Symbolo, Prezi, Image, and R. So here the technology acts as a direct tool substitute with no functional change. Examples of the substitution level. The following are some of the examples for substitution level, such as digital reading software. Digital reading. Here the students can read the e-books of physical textbook with no interactive or enhanced digital features used. The second one is online worksheet. So replacing paper-based worksheet with their digital counterparts in PDF or the Word format. The third one is presentation software. We can use slideshows to replicate the traditional poster board presentation, multimedia or interactive elements. The second, augmentation. At this stage, technology still substitute, but with functional improvement. Here, substitution level, there will be no functional change. But in the augmentation level, there will technology still substitute, but with some functional improvement. It is not just about replacing, it is enhancing. So example for augmentation level is collaboration, digital research tools. These are some of the examples for augmentation level. The third important level is modification level. Modification is where the shift starts getting more significant. Here, technology allows for significant task integration. For example, instead of just writing an essay, students might now create an interactive multimedia presentation. So example for modification level is multimedia projects, blogging for reflection. Multimedia projects such as where the students can create interactive presentation through infographics or to present the research or the project work. These are examples for modification level. The last level is redefinition. Redefinition is a pinnacle where technology allows for of new tasks previously inconceivable. Virtual reality exploration or the global collaboration projects are prime examples. The main example for redefinition are virtual reality platforms, global online collaborations, and AI-driven learning. Here we can compare this with the Bloom's taxonomy. We are having the substitution level is connected with remember. See in the bottom corner, it is connected with Bloom's taxonomy. Substitution is with remember, that is with no functional change. And augmentation. Augmentation here it is a direct tool to substitute with some functional improvement. That is to understand and to apply. And modification is applying, analyzing, and evaluating. And last stage, the redefinition stages, evaluate or create. So in this way, it is connected with the Bloom's taxonomy, SAMR model for the technology integration. The S stands for substitution, A stands for augmentation, M for modification, and R for redefinition. Next slide. Next slide. Here, so with the live example, here the while substitution, no functional change. So we can compare this with the coffee. We all know we used to drink coffee. So technology as a direct acts as a direct tool substitute with no functional change. Then for augmentation, start to show some real benefits of technology in education. For example, spell check or immediate quiz feedback. Here we can compare this with the lathe or cafe lathe. Lathe means it is also a milk coffee that boasts a silky layer of foam as a real highlight to the drink. So here technology acts as a direct tool substitute with some functional improvement. The third one is M stands for modification. The technology allows for significant task redesign. So we can redesign everything. For modification, we can tools that allow multimedia integration. For instance, cater to the diverse learning state and encourage the students to think beyond the text. Here we can compare this with the caramel macchiato. So this is essentially, this coffee is not too sweet, vanilla lathe topped with caramel. So here the technology, significant task redesigning is possible. The last R stands for redefinition. The technology allows for the creation of the new task. So redefinition, it is just not just about the fancy tools, it is about pushing the boundaries of education. It emphasizes skills like global citizenship, collaboration, and preparing the students for rapidly changing world. So the instructor provides readings with online guidance through LMS. So here it is covered with the pumpkin spice. So this is an example for SAMR model of technology. The next one. Next slide. Yes. Yes. Wait. Presentations tools for substitution. Presentation. Up to now, we have seen about the technology, innovative technology. Now, innovative tools for substitution. Presentations are the great way to communicate ideas, and the web presentation tools can make it easier than ever. With these tools, we can reach a new audience, collaborate with the co-workers from all over the world. There are tons of web presentation tools, but which one shall I work actually? I have to spend more time than I care to admit, try different options. Here is a list of presentation tool for substitution level of technology. Next, click once again. Yes, these are the presentation tools for substitution level of technology. PowerPoint online. If we know this PowerPoint online, so which has some pretty cool features like initiative layout. We can access everything from simple to advanced tools such as animation, slide transition, etc. at any point. Then comes Google Slides, Prezi, LinkedIn, Zoho, Flowella. These are some of the presentation for substitution level of technology. Next slide. PowerPoint Online. If we are looking for a web presentation tool, PowerPoint Online is the first one which we can use easily. Next slide. Next slide. Yes, next. Click. Google Slides. Google Slide is a web presentation tool. It has many features which make it perfect for presentation and meeting. We can create animation, transition from one slide to the next easily, or even add the video with some clicks on our mouse. This is a great presentation tool for those who like to collaborate with others. So this is Google Slide. Next one. Next. Next slide. Prezi. What is Prezi? This is also one of the web-based tool for creating presentation. With more novelty, we can create the presentation. Usually, we will do the presentation with PPT, PowerPoint presentation. Prezi is also one of the web-based tool for creating the presentation. It is similar to other presentation software like Microsoft PPT, but it offers some unique features that make it good alternative. In recent year, it has become more popular in schools and business. Most type of presentation software use a slide-based approach where we can move back and forth between the individual slides. It is like kind of pages in the book. But Prezi, however, uses a canvas-based approach. Instead of using slides, Prezi has one very large canvas that our presentation moves around on, zooming in and out to view frames. Prezi is completely free for use. There are upgrades we can pay for to unlock the additional features. But everything we need to create and share a dynamic Prezi is available for free of cost. There is no need to move the slide up and down. But through Prezi, we can move around, we can zoom in and zoom out to view the various frames. So these are the founders of Prezi, Peter Halsey, Peter Aravai, and Adam. Next one. Some more presentation tools were Zoho, Email, Prezi, Slide Doc, Slide Rocket, Powtoon, Go Animation, Haiku Deck, and E. These are some of the presentation tools, and some are free of cost. If you want to do advanced use advanced technology means we have to pay some little amount and we have to buy this. The next one. Next slide. Yes. Technology tools for the classroom. Click once again. These are the technological tools which we are using in the classroom. After COVID, we came to know many of the tools such as Google Map, Google Classroom, Google Calendar, and all we used to that. And some of the tools are also available which we have to use and we can develop ourselves. Next one. Next slide. LMS. So important software in the augmentation level of SAMR. So presentation tools were used for substitutional level of technology, but LMS tool, they are the important software in the augmentation level of SAMR. LMS means Learning Management System. This streamlined the course administration, enabling the educators to organize the content access the students' progress, and facilitate online discussion. These are some of the LMS platforms such as Instructure, Moodle, Drupal, Classroom, Blackboard, Bridge, Canvas, etc. Click again. Click again. Yes, the Moodle. The expanded form for Moodle is Modular Object Oriented Dynamic Learning Environment. Yes, click again. The Moodle, the father of Moodle is, otherwise the founder for Moodle is Martin Dogian. The M symbol in Moodle represent Martin, the first letter in the Martin. He named by his name. Modular object-oriented dynamic learning environment is referred as Moodle. The founder for this is Martin. The M stands in the Moodle logo is Martin. The next tool is Drupal. This Drupal LMS platform is a paid platform. It was found by Dries Biter. The figure is there. Then Bridge and Instructure. They are the founders of the LMS platforms. Next one. Next slide. See, this is important thing. Another important technological, pedagogical, and content knowledge. The TPAC framework. This is referred as TPAC framework. This was found by Punya Mishra and Matthew in the year 2006. This framework identifies three important domains of knowledge. If you see this circle, you'll be able to understand there are three domains. One is technological knowledge, the rose colored thing, pedagogical knowledge, content knowledge. After that, each domain interacts with the other domains. So technology and content, technological content knowledge. Such a way, pedagogical content knowledge and then technological pedagogical knowledge. Practice technological pedagogical content knowledge, TPAC framework. So the technological knowledge, this knowledge about the various technology ranging from the low level technology such as pencil and paper to the digital technology. After that, content knowledge, knowledge about the subject matter, and then pedagogical knowledge, method and the process of teaching, and then combination, technological pedagogical content. It is TPAC frame is knowledge required by the teachers for integrating technological into their teaching in any content area. So with the TPAC, we can see that technology is like a salt, flavoring and broth is true. So technology, TPAC manifests as a variety of skills such as the ability to evaluate and select the right tool to our pedagogical needs. There are 7 components such as content knowledge, pedagogical knowledge, technological knowledge, pedagogical content knowledge, technological content knowledge, technological pedagogical knowledge, technological pedagogical content knowledge. So example for TPAC for a social science class might be the knowledge of how to manage and access the student contribution to the discussion forum. TPAC is very useful. And then in the fast digital era, the landscape of education is evolving rapidly. Innovative teaching methods are reshaping the traditional classrooms. So here is a closer look at how educators are leveraging technology to transfer the educational experience. Nowadays, we are using flipped classroom, gamification of the classroom, online collaboration platform, personalized learning path, etc. So TPAC is very essential. So next one, next slide. The TPAC framework was first introduced by Punya Mishra and Matthew of Michigan State University in the year 2006. It is very useful one. Next one. Next slide. Next, yes, TPAC level and SMIR level. 2 technologies we can compare with our Bloom's taxonomy. So remembering, understanding, applying, analyzing, evaluating, and creating. So TPAC level 1, 2, 3. 1 is referred to substitution level, 2 with augmentation level, 3 with modification level, and 4th one with the redefinition. So blue taxonomy is based on the SAMR and TPAC model. Next one. Next thing. Advantage of the digital education for the students. There are various advantages like it can make the student acquainted with the digital technology and tools, deeper involvement of the teachers and the parents, better engagement rate, makes the students more accountable, extensive learning opportunities, motivate the student, make students smarter and personalized learning. Thus, tools and technology, there are many innovative tools and technology which are used in the field of teaching and learning. Thank you. Thank you for the opportunity.